For the next few sections, we're going to be continuing our review of geometry and just some applications of geometry into algebra and moving towards pre-cal. So in our last section, we did sine, cosine, tangent, so we did trigonometric functions. In this section, we're going to do area and the law of sines, and then next time we'll do law of cosines. So if you had me for geometry last year, we definitely did these. So hopefully you remember them, and they'll be more familiar to you, and you won't have to whine and complain. So our central question is, how do the trigonometric functions relate to the trigonometric ratios of a right triangle? So our objectives are to find the area of any triangle by using one angle and two sides, and also by using the law of sines to find missing measurements of triangles. Okay, so for review, to find the area of a triangle. So we learned area of a right triangle is a squared. No. Hold on a second. Okay, sorry, I put my brain in. So area of a triangle is 1/2 the base times the height, but you won't necessarily always know those values. So you can use 1/2 of sides B and C times the sine of angle A, 1/2 AC times the sine of angle B, and 1/2 AB times the sine of angle C. So this is if you know one angle and you know two sides, or two of the sides. We can't always necessarily find the third side if it's not a right triangle, but we can find the area still anyway. Alright, so let's do a problem. Just a moment. Okay, here we go again. Finding the area of a triangle. Okay, so here we have this triangle. We want to find the area of triangle ABC to the nearest tenth of a square mile. Okay, so from our formula, the area of a triangle, you can go from the angle that you have, and you can use two other sides. So if you remember, angles and their sides are opposites. So angle A is a capital A, side A is a lowercase a. Angle B is capital B, side B is lowercase b. That's B. Angle C is a capital C, side C is a lowercase c. So we use from our angle the sine of A, well no, hold on, 1/2 BC times the sine of A. So our area is 1/2 BC times the sine of A. Okay, so side B is 5 miles, so we have 1/2 of 5 times C is our 10 miles, and then multiply that times the sine of 31 degrees. Okay, in order to put that in, you could just put that all into your calculator. Just put that in. You could do, this is 50 divided by 2 is 25. You could put 25 sine 31 into your calculator. That will also work. So go ahead and put that into your calculator. See what you get for your measurement. I got 12.9 miles squared. Remember, we're measuring area. Area is miles squared. Okay, so that tells you how much area that triangle covers, even though it's not in a nice, pretty form that we would love to be able to use. Alright, we also have the law of sines. Hopefully you remember this one. In any triangle, the ratio of the sine of each angle to its opposite side is constant. In particular, for triangle ABC is labeled as shown. So you see how capital A, lowercase a are across from each other. So sine of A over A equals sine of B over B equals sine of C over C. So you can use those ratios in order to find missing sides or missing information. So in triangle PQR, the measure of angle R is 39 degrees, the measure of angle Q is 32 degrees, and PQ equals 40 centimeters. What is RQ? Okay, so when you get problems like this, the first thing you're going to want to do is to draw a picture. So we know we have a triangle. We're not sure of all the dimensions, but we know that we have P, Q, and R. Are its names. We know angle R is 39 degrees. We know angle Q is 32 degrees. And we know side PQ is 40 centimeters. So they want us to find out what is the length of this side. Okay, so in order to find the length of that missing side, what we need to do is we need to make a comparison, a proper comparison. So angle over side, angle over side. Now, the side that we want is this one here. So we need the angle, the sine of the angle, so sine of 39 over 40 equals, now we need the sine of this angle here over this side that we don't know. But we don't know what that side is. So in order to find that side, we need to use our information of what we know about triangles. We know there are how many degrees in a triangle? Well, there's 180 degrees. If we subtract 39 degrees and 32 degrees from the degrees that are already being used in the triangle, we're left with 109 degrees. So angle P must be 109 degrees. So then we have the sine of 109 over our missing side, and that's RQ. Okay, so if we were to go ahead and simplify, we can cross multiply. Let me grab a different color here, just for clarity's sake. So x times sine of 39 equals 40 times the sine of 109. And then to get x by itself, you divide by sine of 39. By sine 39. So then you put into your calculator 140 times sine of 109 divided by sine of 39. Go ahead and put that in. You should get 60.1 centimeters. Hopefully you got the same thing I did, and that would always be good. If you didn't, check and make sure that you are in the proper mode. Make sure that everything's working well. Make sure you use parentheses where you need to. So you might have to put parentheses around this, possibly, depending on how your calculator works. Alright. And there's all that stuff again. Okay, so finding an angle of a triangle. So we found a missing side. What if we need to find a missing angle? In triangle RST, T equals 7, R equals 9, and the measure of angle R equals 110 degrees. What is the measure of angle S? So I'm just going to draw a triangle here. I know that I have one angle that's larger than the others. So this is 110 degrees. So I'm going to name this one R. And it's RST. We know that side R is 9, so that goes across from angle R. And we know that side T is 7, that's across from angle T. Okay, so there's our information. Then we want to know, what is this missing angle over here? What is this angle right here? Okay, so let's go ahead and use our law of sines. So we have an angle and a side. We want this angle, but we don't have this side. So can we use some process of deduction in order to figure some stuff out? We can find angle T, and then we can use that to find angle S. That sounds like a good idea. So let's use, so our end goal is to find angle S, but in the process we need to find angle T. So let's use our law of sines to find angle T. So we have the sine of T over, side T is 7, equals the sine of our angle R, that's 110 degrees, over our side R, which is 9. So if you wanted to solve for T, first thing you do is multiply both sides by 7. So sine of T equals 7 times sine of 110 divided by 9. Now, hopefully you remember from geometry, when we don't know the value of an angle and we want to get rid of sine, we can't just divide by sine. Sine has to have some value associated with it. So instead what we do is we multiply by sine inverse. So T equals sine inverse of 7 times sine 110 over 9. So you have to put all this into your calculator. Sine inverse is located in the same place as sine. You usually just have to hit second or shift. So go ahead and put that into your calculator. Find the measure of angle T. Well, the measure of angle T equals 47 degrees. So if T is 47 degrees, can we find out what the leftover is? for our angle S? Well, we know there are 180 degrees in a triangle. We used 110 for angle R. We just used 47 degrees for angle T. So that leaves us with the measure of angle S is equal to 23 degrees. Alright, so that's for finding a missing angle. There you go, there it is again. Okay, so using this in a problem, so I couldn't find a good way to get this picture without all the words, so enjoy the words. A surveyor locates points A and B at the same elevation and measures distances and angles as pictured. So they want to know what is BC, the distance from B to the summit. So BC is this length right here. So they want to know, what is this length? Okay, well right now we don't have a whole lot of information to go off of for this right triangle over here. If there were more information for the right triangle, that would be really handy. And that would make this really easy to solve. But of course, you know, that's not how these things work apparently. Okay, so what we're going to do is, let's start by finding this angle here. So we know that there are 180 degrees in a line. If 31 degrees is used up on this part of the line, then what's left on the other side? Well, 180 minus 31 degrees is 149 degrees. So angle B, or angle ABC, is 149 degrees. Then we can find what this angle is by looking at the whole triangle. So we take 180 and we subtract 18 and we subtract 149. So then we have, for angle ACB, we have 13 degrees left. So this angle up here is 13 degrees. Now, do we have enough information that we can use our ratios in order to find this BC length? Yeah, we can use our law of sines. Okay, so we have the sine of A, this is angle A over here, over the side that we want to know, equals the sine of C, which is that one that we just found up there, over AB, those sides there, just so you can see where I'm getting all the information from. So we get sine of 18 over x equals sine of 13 over 3,950. Okay, so in order to solve this one, we're going to need to cross multiply because we've got a lot going on here. So we're going to cross multiply, and I get x sine 13 equals 3,950 times the sine of 18, and then divide by sine of 13. Sine of 13. Okay, so in your calculators, you're going to put this lovely mess. 3,950 times the sine of 18 divided by the sine of 13. Okay, what do you get for your value of x? That should be the height from B to the summit. So if you were to take that trail, you should have gotten that 5,426 feet. Beautiful. Okay, now if we wanted to instead find the height of CD, so the height of the mountain, what could we do for that? Well, we can use all the same information that we had before. Let's see. We know that, I wish that I had kept my other drawing. Sorry about that. Give me just a second. I'm going to pause the video, put all the stuff back onto the drawing, that way we can see it again. Alright, I added our information back into our picture. So we can assume that since CD is a point straight up and down, that this is a right triangle. So if this is a right triangle, how do we find what this length is? Well, we know one angle. We know our 31 degrees. So let me grab another color that might be a little easier to see. Okay, so we have from our angle of 31 degrees, our perspective, we want this side, which is our opposite, and we know our hypotenuse. So which of our trig functions relates opposite and hypotenuse? Well, that's our sine function. So we're going to use sine of 31 degrees equals our opposite side, x, over our hypotenuse, which is 5, 4, 2, 6. So to solve for x, you multiply both sides by 5,426. So x equals 5,426 times the sine of 31. Go ahead and plug that into your calculator. What do you get for the height of the mountain itself? I got 2,795 feet. Alright. Hopefully that all made sense to you. I have your lesson check here. Make sure you do these two problems. Compare them with your partner when you get to school and when we start class right away. And your homework is to do lesson 14-4, and have a great night.